Oh, it's great. Lesson 35 today, similar and congruent polygons. Objectives, identify corresponding parts of similar and congruent polygons and understand the relationship between them. Determine that triangles are similar when their corresponding sides are proportional in length. Determine that triangles are similar when their angles are congruent. Use relationships between sides and angles of similar when their angles are congruent. At this point, you can do your power up. Go ahead and freeze. I am going to move on. Vocab, having the similar is having the same shape, having corresponding sides, proportional or corresponding angles equal. Congruent is when things are the same. The angles are all the same, and so are the sides. So, I'm going to label these triangles. Alright. A, B, C, D, E, F. Okay? And you want to do corresponding angles. Well, angle A is the same as which angle on D? Well, or on the other triangle. Well, angle D would be the equivalent to that. Angle B would be the corresponding angle to that would be angle E. Okay? Okay, now angle C is going to be similar to angle F. Okay, now I need corresponding sides. AB is going to be similar to line DE. Okay? And BC is going to be similar to EF. And then you're going to have CA is congruent to angle FD. Okay? Now, things about that. Make sure that they are going with the right one. Make sure you read it through all in the same order. Because if you start going the wrong direction, you might do it incorrectly. Okay. Similar polygons. Similar polygons have corresponding angles which are the same measure and corresponding sides which are proportional in length. Congruent polygons have corresponding angles which are the same measure and corresponding sides which are the same measure. So basically, if you are congruent, you're the exact same. If you're similar, your sides will be a little bit different. Which two quadrilaterals are similar? Similar meaning they are the same shape, their angles are the same, but their measures are proportional, not equal. So, got the same measures here. Now, one that I'm going to outrule right away is probably D, because your angles aren't even going to match up. Okay? Another one, I think there's one more you should be able to eliminate before you think too much about it, but maybe you can't. It kind of depends on what you're seeing here. Okay, so let's do proportions. Okay, this side is 12 over 8. This over that. We're going to also have 4 over 6, because that would be the top once again, over the side. And we're going to have B, which should have been first. Let's do that one first. 8 over 6. And we are going to have 4 over 6. Which technically, we should flip this and rotate it. And no one said that it could be the same if we rotate it. And then our 100 would be in this corner, our 80 would be there, which would be a 6 over 4. Reduce these down, I can divide this by 4, divide this by 4, I end up with 3 over 2. Divide this by 2, divide this by 2, because I can't take a 4 out of 6, I'm going to end up with 4 over 3. Divide by 2, divide by 2, I get 3 over 2. So A and C would be the correct answers. Are the two that are similar. Okay. Side, side. So we're talking about triangles here. Triangles are similar if two triangles have proportional corresponding side lengths, then the triangles are similar. Angle, angle, angle similarity. If the angles of the two triangles are congruent to the angles of another triangle, then the triangles are similar and the corresponding side lengths are proportional. And that should be hold true. But, yeah. So, triangles are similar. Find x. This is using side, side, side. So I can create a proportion. A proportion we learned the other day was something over something. This time I'm going to go with 3 over 5. Okay? That means this side goes with this one. So it's going to be x over 15. Well, how did I get there? I multiplied by 3 to get the bottom, right? So what I do to the bottom, I must do the top. I get x equals 9. You could also cross multiply if you wanted to. An architect makes a scale drawing of a building. If 1 inch on the scale drawing is 4 feet, then what is the scale factor for the building to the actual drawing? Okay, when you're thinking about this, you are going 1 inch on your drawing represents 4 feet. So, if 1 inch on a drawing represents 4 feet, then what is the scale factor from the drawing to the actual building? Okay. To make sure you don't get those wrong, necessarily, you would want to change this to inches. So the actual would be 1 inch. And how many inches are in a foot? 48. So it'd be 1 inch to 48 inches. What is the length of a room that is 5 inches by 4 inches on the drawing? Okay? And the reason you'd want to go to this is it's much easier to multiply then if you have to keep your measurement in inches than if you keep it at feet and then you come up with a decimal. So in this case you have 5 inches by 4. Well, you're gonna take your actual dimensions, which is 48 for every inch, times that by 5, you're gonna get 0, 4, 24. Okay, you're gonna go 48 times 4, which is 2, 3, so that should get you 192. You would add these two together. Let's see, it doesn't say find the area. So, you would have, you'd have 240 inches by 192 inches. Okay? Okay, you'll do your practice set, and then do your written practice, and there is your homework.